This is number 6 from the non-calculator portion of the test. We'll start number 6 by reducing the fractions, the coefficients and the fractions. The 9 we can reduce with the 12. There's the 3 that go into 9 and 12. The 9 becomes a 3. The 12 becomes a 4. The 5 and the 15 can reduce. 5 goes into 15 3 times, so the 5 becomes a 1. The 15 becomes a 3. So let's multiply. We have 3 times 3, which is 9. X to the first times x to the negative third gives us x to the negative second. Y to the second times y to the second is y to the fourth. Again, remember, multiplying the same base, you add your exponents. Over 1 times 4, which is 4. X to the negative second times x to the third, adding negative 2 and 3 results in an x to the first, and then y to the third times y is y to the fourth. We then need to make all negative exponents positive, so we'll do that by dropping this x to the negative second to the denominator. So we'll have this x times x to the second, and then y to the fourth and y to the fourth cancel out. So our final result will be 9 over 4x to the third. And number 7. Okay, in number 7, we will distribute the negative second to all these terms. X to the fourth raised to the negative second, power to power means you multiply. X to the negative eighth, y to the second, over 3 to the negative second. We need to make all negative exponents positive. We'll do that by dropping from the numerator into the denominator x to the eighth, and raising 3 to the negative second to the numerator as 3 to the second, carrying along our y squared. 3 to the second is 9, y to the second over x to the eighth. Okay, we can go on to number 8. On the back of the review guide, on the back page, it says to describe the end behavior. If you remember, we have odd and even functions. We determine whether or not it's an odd or even function by looking at the exponent on our largest term. This is an odd function. If you recall, odd functions are shaped from down to up or from up to down, depending if it's positive or if it's negative. And our even functions are either going to have end behavior that is up, up, or down, down, depending if it's positive or negative. Okay, so determine if it's odd or even, you look at the exponent of the highest power, highest term. So we have an x to the third, so this is odd. But the coefficient of our x to the third term is negative, so it is a negative odd function. Therefore, our end behavior is going to be up, down. Over here, we have the highest power is raised to the fourth, so that is an even function, and our first term is positive, so this will be a positive even function. Therefore, our end behavior will be up, up. In number 10, we have to sketch the basic shape on this graph. So to do that, we first need to find the zeros. The zeros are our solutions to this graph. what number makes this factor 0, what number makes this factor 0, and what number makes this factor 0. Here, x will equal -2, x will equal 4, and x will equal -6. So we can quickly sketch those points on our graph. -2, 4, and -6. Now to determine end behavior, we have to get the total exponent for this whole function. Now if we would multiply this x plus 2 and expand it out to the third power, we would end up getting x to the third is our highest power here. The rest of this doesn't really matter, we just need the highest power. So we'd have x to the third, this one times this term, which would be multiplied out, and the highest power would be x to the fourth, and then we would multiply it by this term, which is just going to be x. Again, the rules of exponents when you have the same base is to add exponents. So this function would end up being an x to the 8th function. Since it's an x to the 8th function, it's going to be even and it's positive, so it will be an up end behavior. So I like to graph end behavior first. Our end behavior is up. That means from the farthest 0 to the left, it's going to be coming up off of that 0. So we can sketch that first. And this one will also be going up, so we can sketch that second. Now to determine whether or not our graph goes through the 0 or if it bounces off, you have to look at the multiplicity. The multiplicity means how many times does this 0 occur. The 0 of, we'll start from the left, this is the 0, -6. -6 has a power, this factor has a power of 1. So the multiplicity is odd because it has a power of 1. So since it's odd multiplicity, the graph will go through the 0. So we'll bring it down through and take it up to the next 0. Now it's going to hit this 0, which is the 0 of -2, and we have to determine if it's going to go through that 0 or bounce off. Since the multiplicity of the root -2 is 3, 3 is odd, so this one also has odd multiplicity. Odd means we're going to go through. So this 0 will go through and back down to the next 0. And this 0 of 4 has a multiplicity of 4, and that is an even multiplicity. And since it's an even multiplicity, it's going to bounce off. So this will bounce off and go back up. And that's a basic sketch of this graph. Using the same reasoning, we need to figure out what type this graph is, the highest power of x, if we would multiply this all out. So we have an x to the fourth times an x to the second times an x to the fifth. We need to add the exponents. 4 plus 2 is 6, 6 plus 5 is 11. This would be an x to the 11th graph. That means this is an odd function. Again, odd function means we'll start down and end up going up. So it will be somewhat like that. So our end behavior will be down, up. Let's get our zeros. The 0 for x to the fourth is 0. The 0 for x minus 4 is 4. And the 0 for x plus 5 is -5. So we can graph those solutions on our graph. -5, 0, and 4. We said the end behavior is down up because it's a positive odd function. So we'll come from the farthest left 0, we'll start from down and come up to that 0. And this 0 at the far right will end up going up. So those are our end behaviors. Now we need to look at the multiplicity of each 0 to determine if the graph goes through or bounces off the 0. So we'll start with the farthest left 0, which is -5. -5 has an odd multiplicity. So since it's odd, it will go through and come back down to the next 0. That 0 is 0. Has an even multiplicity. So since it's even, it's going to bounce off, come back up, and then come back down to that next 0. And again, the 0, 4 is even because it has a multiplicity of 2, and therefore it's going to bounce off that graph as well.